Hello, ladies and gents. A couple quick things. We're going to be starting finding order and diversity. Some of you have gone over parts of this with me, and some of you haven't. So let's get started. Why do we assign scientific names? So there are hundreds of human languages for scientists to be able to communicate and research effectively. Each animal needs a unique scientific name. This means if a scientist, say an English scientist, is working with a Spanish scientist, who's working with a French scientist, who's working with a German scientist, it makes it so much easier if they all use the same name for the same species. Excuse me. If they're using Ursus whatever, some sort of bear, they want to be calling it the same name throughout so they don't get confused, they don't get mixed up. The classification system we use allows for the scientific name to give us hints as to what relatives each organism has without a ton of work. So when we talk about things like Canis lupus and Canis familiaris, Canis lupus being gray wolf and Canis familiaris being your pet dog, we know that they're closely related because of that Canis genus that they have. And we'll talk about genus and species in a minute here. What is binomial nomenclature? Binomial nomenclature is the two-word naming system made by Carolus Linnaeus himself. Each organism has a two-part name written in italics. It should look like what's on here, this guy, genus, species. Genus being capitalized, species being lowercase. So the examples are below. Canis familiaris, you can see genus here, genus here. Genus is capitalized. Species is not capitalized, and I put the common name off to the side. Canis lupus, gray wolf. Canis, again, same genus as dog. Lupus, different species than dog. So that is gray wolf. On a separate sheet of paper or on a document online, either way, I am going to ask that you find 3 more scientific names for the common organism, for random common organisms, doesn't matter what. Please write them in the same format as above, so in italics, your genus, your species, and then a little space away the common names so that I know what you're talking about. I'm going to have about 6 questions like this throughout my slide set, throughout my video, so that I know that you're on top of this, you understand what's going on. If you have questions about the numbers, the questions, if you have questions about the questions, please let me know and I will help you through them, okay? All right, moving forward, go ahead and pause here if you need a moment to get this done, which you probably do. It's going to take some Google and some help to get 3 more scientific names. All right, continuing on. Systematics is our next topic. Systematics is just the science of naming and grouping organisms. So this science behind naming and getting all this stuff done. The groups made by systematics are what are called taxa. So a genus as a group, several genuses are taxa, right? Phyla is a taxa, right? The taxa we use in biology always go in the same order, which is on the next slide. Please take a moment, pause my video, and go to the slides and watch the crash course video. This goes more in depth into systematics. It goes more in depth into taxa. It uses a ton of vocabulary words that we're using in here, and it's just going to be a fantastic use of your time. It's going to be a great way to help you memorize kind of what these words are, to listen to them again, to think about them again. All right, please do that now. Pause if you need to, what have you, and then we're moving forward. So the taxa here, excuse me, I'm a bit sick. The taxa here go in this order, domain being the very largest, encompassing all kingdoms, kingdoms being second largest, down to phylum, class, order, family, genus, species. The way we remember these, Dumb King Philip can't order 5 good sandwiches. If you remember that mnemonic device, you're going to have quite a bit of an easier time getting through the memorization of kind of the order of these guys. Coconuts are not mammals, just clarifying that right now, you can try, but they're not mammals. Moving forward. Characteristics of major taxa, page 524 of the packet. So if you have the packet, if you were here Friday, you should have the packet. 524 is about 4 or 5 pages in. It's at the very bottom is this chart. I know it's fuzzy on here. I'm sorry, guys. There's not a whole lot I can do about that. I did what I could with what I had. The one on the bottom of 524 is much better. It's much clearer. If you can't read this and you don't have anything else, please feel free to just Google classification of living things. You might find a better one than I did. I can kind of read it from here. It's bad, but I can still kind of read it. So I think you should be okay. So we have this open for the next few questions. Moving forward. Questions here, obviously on the chart on the previous slide or on 524 of the packet. Which kingdom has cell walls made of chitin? So you're going to go into that chart. You're going to find the kingdom. So you go over the top for the kingdom and you go down to look which one has cell walls made of chitin. Which domain has the most kingdoms in it. Make sure you know the difference between kingdom and domain. They are labeled, so it shouldn't be too bad. And which two kingdoms have only unicellular organisms? So you're going to look at the You're going to look at the 6 kingdoms, not 2. And you're going to find the ones with only unicellular organisms. Please do that now. Take a moment, pause the video if you need to, and then we're going to move on. Okay, dichotomous key. This is one of my favorite things to do in bio, just because I feel like a dork getting to jump through it and have fun jumping through it. So here's what I'm going to do. I'm going to give you A, okay? I'm going to work you through how to get there, and then you're going to find the answers to B through H for the fifth question that I'm giving you, okay? So I'll work you through how to get A. Now A is circled here in red. So A is a nice, smooth, dark green leaf. So one says, is it needle leaves or is it non-needle leaves? I would say this is definitely not a needle leaf. Needle leaf would be more like D and E. So let's go to non-needle leaves. So let's go to 3. Here's 3. Is it a single leaf or a compound leaf made of leaflets? So simple or compound? I'm going to say it's a single leaf. A compound leaf would be one with a stem that has multiple leaflets or little leaves coming off of a single stem, whereas ours has a single stem and only one leaf coming off of that single stem. So I am going to go to, I'm going to go to 4. Down to 4. Is it smooth edged or jagged edged? It's very clearly very smooth. So I'm going to go to 5. Leaf edge is smooth, magnolia. So for A, I'm going to put magnolia. For leaf edge is lobed. It shows white oak here. A lobed leaf, I want you to think of like an earlobe. I want you to think of kind of a swishing back and forth deal to kind of show that lobiness, to kind of show that chunkiness that leaf would have. All right, so you are up for doing B, C, D, E, F, G, and H. So please go for it. If you're struggling with what this comment means, I am very disappointed in you. We definitely went over genetics. You've got this. All right, moving forward. Final question. You are going to gather 5 random household objects. They can be simple, like pens, pencils, paper, or they can be more unique objects. It's up to you. You're going to make a dichotomous key from those objects. I have a dichotomous key on the next slide that I'm going to walk you through how I did. You may not use the organisms on my dichotomous key. You do need to make sure that they're your own, okay? So first thing to remember, before I get started showing you what I'm going to do, remember to avoid ambiguous terms like big or small. Be more specific than that. Think about this. An elephant is big to a mouse, but a mouse is big to an ant. If you need to use big or small, say something like larger than a car, or smaller than a pair of glasses, larger than this, or smaller than that, right? This gives you a more real start and stop point that's going to help clarify your dichotomous key. This part helps, but you don't really need it. Let me show you. Alright, so these are for my pets. I got dogs, mostly big dogs. Got a couple goats, horses, chickens, cats, rats. Okay, so when I look at this list, the first thing I notice is goat and horse, they both have hooves, right? I can kick those out of my basket right now so I don't have to worry about them. So here's what I'm going to do. I'm going to go animal has no hooves, animal has hooves. I'm putting animal has hooves, go to 2, animal has no hooves, go to 3. I'm going to worry about 3 later. I'm going to do 2 now. So I'm going to go to 2. Animal has horns, goat, animal has no horns, horse. Goat and horse, check off, they're done, okay? Now I need to go to 3, animal has no hooves. I still have chicken, cat, rat, and dog to get through, so that I don't have to, so that it can be done, basically. So I got rid of chicken really fast because that one makes sense. Animal has no visible ear, or animal has visible ears, go to 4. Animal has no visible ears, go to chicken. When you look at a chicken, you don't see like little pointy ears like a cat, a rat, or a dog would have, making it really easy to just kind of check him off of the list. I could have also said has 4 feet, has 2 feet. There's a lot of different ways to get rid of a chicken. Alright, moving forward. The animal is regularly larger than a brisk tea can. You know, those Arizona teas, those brisk teas that are like gigantic. That's what I'm talking about here. Or animal is smaller than a can of tea. The rat is definitely smaller than a can of tea. Vast majority of cats and dogs are not smaller than a can of tea. You could argue like a teeny tiny chihuahua, but my rats were only about a pound. They definitely were not as big as a small dog. So I'm going to say smaller than a can of tea works. And then larger than a can of tea, go to 5. So now I'm down to cat and dog. How I differentiated them was I said has retractable claws as a cat, does not have retractable claws as a dog. And I'm finished. This is it. Okay? So I have my 5 steps. I have 2 options per step, and it finishes out and gets rid of all of these guys, which clears everything up really nicely. All right, moving forward. You've got this. Just a little bit of Dory to brighten your day. Just keep studying. Please let me know if you have any questions at all, and I will definitely help you out. I know this video went a little bit fast, but I do have time limits because of the way YouTube is. So, if you have any questions, again, let me know. Best of luck, y'all.